Finally. Okay, good. Ha ha ha. Maybe. Oh, wait, I think I've been live for a couple seconds. Can someone do me a favor real fast? Because I think I have made a interesting mistake here. At 3:30? So it's really not, you're not really not seeing anything, huh? Huh. Live. It says I've been live for 3 minutes. Well, maybe we should just wait just for 2 seconds then. I'm not so sure about that.
You're live right now.
Yeah, I was like, I think I'm live. Yeah, okay, great.
Started streaming less than 1 hour.
Yeah, okay, great. Well, let's keep going. Let's start, shall we? It's nice to be streaming again. Things are a little bit different now. YouTube continues to change everything, so it's kind of hit and miss, and for that I do honestly apologize. As I mentioned earlier, this is the first time I've streamed this semester, so it is not without its problems, as always, on the first time. Okay, so today I want to continue our conversation about programming. We spent the last hour and a half or so, maybe even longer, talking a lot about our prototypes, looking at them critically. I hope you honestly take all that information and feedback to heart. We need to motivate our players at an emotional level. We want to make sure that we're asking them to do something, to behave inside of our game. They're just not going to randomly do it. We can't assume that they're going to want to do these things. We almost have to force feed it down their throats, okay? We have to grab their hands and we have to yank them into our experience. And if we appeal to them at the emotional level, they're going to want to play our game, and a behavior is going to be inspired. Okay, all good game designers understand that in order for a player to do something, we need to understand why we're asking them to do what they're being asked to do. Game design at the largest and most kind of macro level is an exploration of why we do things, and then we motivate our players to act on that why. With that said, let's jump into some programming today. Every week we're going to continue taking baby steps into a much larger programming world and infusing interactivity inside of the games that we create. Last week we spent some time talking about what? User interface stuff, simple little buttons, and I thought it might be good just to kind of refresh ourselves real fast with that structure and that architecture. It's pretty easy. Let's go ahead and start doing something here with these buttons. Okay, this is going to be my silly little demo scene, and before we get started, let me just save it, and I'll call this level _01. And to start things off, let's create a new scene inside of my project. And of course, immediately I'm going to save it. And we'll call this main menu. Okay, great. Now, pop quiz. Some of you guys asked this a little bit earlier. How in the world do we influence the background of our environment? How do we change that gradient if we want? Let me show you. This is actually kind of interesting. Inside of Unity 5, we're working in a physically based rendering environment. So the environment, this grand skybox, is going to have a direct relationship on how things are shaded inside of our scene. But we can change this. We can go in and influence how all of this kind of works, okay? And it's pretty easy to do so. First and foremost, let's look at the role of the main camera, because if we don't want this gradient, and maybe we just want to have a singular color in our environment, or hopefully some of you guys have started to play with textures. The main camera over in the inspector gives us some options on what we want to put in the background. Okay, right now we're rendering our skybox, but if we change the clear flags channel from skybox to solid color, now this background color is going to become a player and will allow us to very easily change our interface to look however it is that we want it to look. Okay, so that's the low-hanging fruit. It really is, just changing it to a solid color, which is kind of fun. Okay. Now, if you want, you can absolutely go in and continue to massage this a little bit let's pretend that we want to have that background color in there. And we want to have a skybox that defines how our environment's set up. Well, that requires us to go in to a new panel. Some of you guys have stumbled upon this, others have not. But in Unity 5, in order for us to change the global illumination system and really affect the lighting at the environment level, we have to go to the top of the screen where it says Window. And at the bottom here is a new panel called Lighting. And if you look at it, check it out. Here is the series of channels and options that are directly going to control how our light system, our environmental lighting system is going to work. And you can see there, the first channel there, we're loading in the default skybox. Now, we really can't go in and change the default, but if we wanted to, we could absolutely create our own and create our own environment, whatever colors that we want. In addition, this is something that's kind of nice. You can also change the ambient intensity. Without any geometry inside the scene, we're not going to have an effect on this. But this adjusts the intensity and the influence of our environment on our assets.
Where did you find that menu?
At the very top of the screen where it says Window, and the lighting options towards the bottom of that list. I think what I'm going to do, just to kind of demonstrate the functionality of this channel, is to create a new skybox. Leave this window open. We can create a new skybox simply by traveling over into our Projects tab, choosing the Create button, and believe it or not, it's in the material. A skybox is the material. And let's just call this Epic Background. Awesome. Okay, cool. And then if we change our shader type from the standard shader to skybox, and we'll do procedural, so that way we get to control it. If you choose the six-sided or cube map options, you're going to be asked to load in a whole series of images that will determine how our skybox is drawn inside the scene. The procedural one, though, check it out. We have a lot of fun here, okay? We can change a whole series of different values. Of course, we get the tint, the sky, and our ground to get what we're after. So I can make my sky very red, my ground, I don't know, something else, very green, or any combination thereof. I'm looking at this little preview window down here to really gauge my effect. You can change the exposure, make it brighter or softer. You can also change the atmosphere a little bit. So there's a lot of options in here that you get to control, including the size of the sun inside of these parameters. Now, we've just created our backdrop, our skybox. We haven't loaded it in, which is why down here in the game view, nothing's changed. If we return to our lighting window and load in our new skybox material in this channel box here. So where is it? There it is, Epic Background. Now, whoa, we're in this wonderfully weird pink and green world. So a couple different ways to have fun with skyboxes and continue to work with them inside of our scene. I think for the purposes of this example on my main menu, I'm going to go back to my main camera and choose its flag to be solid color, so I don't have that weird gradient happening in the background. Make it a little bit easier to see the impact of these buttons. Okay, so walk me through real fast the creation of some buttons inside of Unity. What's the first thing that we need to create? So you want to have like a play button and a quit button. That was the example that we worked with last week. Let's just do it super fast. So in order to start off, we're going to create the canvas in which all of our text elements are going to go within, the UI itself. So game object, UI, and let's just throw in a text element. Okay? Now the moment we create this text element, Unity is going to choose to think about it for an extraordinarily long, unfortunate period of time. Don't know why I'm getting the beach ball of doom here, but I guess I am going to get the beach ball of doom. Aha, great. And if we look at our environment over here, we can begin to see our canvas, and this is our canvas. This is what is that little white box inside of our editor, our scene editor? Yeah. Specifically, what's going to show up in that box? Our GUI elements. It's a physical representation of our screen. And hopefully you noticed this a second ago. Check it out. Watch what happens when I resize this bottom window. Watch what happens to my canvas. What's happening? Yeah, it stretches. It also moves. It really is a physical representation of what we see down here. Now, we haven't talked about this yet, so I wouldn't be too surprised if you guys don't know what I'm talking about. But in every sense, this pull-down menu controls what we see inside of our game window. Right now, we're under free aspect, which is why when I change the size, my canvas responds. Okay. If I make it a really funky size, you can see it happening down there. But we also get some controls in here. This is a little bit more important when we start getting into development of very specific games. We can lock it to an aspect ratio of like 16 by 10, 16 by 9. Most computer monitors, unfortunately, are 16 by 10. Most televisions these days are 16 by 9. iPads, and I can't speak for a lot of the Android devices, but I know that originally an iPad had an aspect ratio of 3:2, I believe. I think the Mini is different now, but we can change these. And of course, we can also create our own if we're authoring our game for a very specific device. Let's just do 16 by 9. And now, no matter what, my canvas is going to stay the exact same size, which is pretty cool. Okay? All right. So let's start positioning my text element a little bit more directly. Now the text element, I'll make this smaller. There it is. There's my text element. Let's move it into position here with the move tool. Let's get it on the canvas. And FYI, you can also do it numerically as well. Over in our inspector. Wonderful. Okay. Great. Looking good. I'm liking that. Okay. And let's just call this play. Wonderful. There's our play button itself, or the text element. It's not a button yet. All we've done so far is just made it a on-screen text. I'm going to make my button a little bit bigger, but I also need to ensure that I'm changing the size of my bounding box for this object to incorporate and include. There it is. By increasing the height, we can make it a little bit bigger. You can also grab. Oops, not that one. I apologize. There used to be an interactive way. I grabbed the wrong one. It's not this one right there. It's this guy right there. That's the rec tool, which will allow you to interactively change the width and the height of your button. So that's a really fun way of working with it. Now let's see. For the text element itself, I'm going to center align this both horizontally and vertically, so it's always in the center of that box. Looking pretty great. Okay. I'm also going to change the color to white, so that when I add the button component, the rollover channels, the rollover color values of that button are going to influence this GUI element. Okay? Now at the moment, this is just a text element, so let's make it into a button. By going to the bottom of our inspector here, I can add a component, UI, and now I want to make my text element not just a button, or not just a text element, but a button too. So we have the text script, but now we have a button script, and this is why I wanted to go in and change the fill color of my text to white so that my normal highlighted and pressed colors can be influencing my scene. Let me show you what I'm talking about. When the fill color is white, now I can leverage this a little bit more directly. Let's make our button kind of a nice medium gray. And then the highlight color will make a lovely shade of yellow. Somewhere right around in there. That's probably pretty good. Okay. Let's play the game, see if we can get that rollover functionality working. There it is, great. So it's working. We'll stop the game. You can also do a pressed color if you want, just to proof of concept, we'll do red. Play the game. There we go. And you can see when I click on it, it flashes red. So all of that functionality is built into the actual button script itself. It's pretty great. You can check out these other different ones. We'll talk about the animation one going forward in the future. If you want to look at the online documentation and the tutorials on the Unity website to explore sprite swap, I would definitely encourage you to do so. At the core of the Unity UI system, it understands the roles of sprite graphics. It's pretty neat. The online documentation and tutorials do a great job, probably a much better job than I'll ever do in describing that functionality. Okay, I'm going to leave it at color tint because that's all I really need to do at the moment. Since this is looking pretty good and is representative of what I want my buttons to be, let's duplicate it real fast. I'm going to be a good steward of my hierarchy and rename this game object play button. Let's duplicate it by right-clicking, choose duplicate. Now, this isn't going to be the play button. This is going to be the quit button. Awesome sauce. Okay, great. Let's take my quit button and move it down somewhere right around there. And of course, we're going to need to change the on-screen text as well. Groovy. There it is. There are my two buttons. Okay. I'm very generally pleased with them, with the way they're looking inside of my scene. I'm going to move them up just to kind of center them a little bit more. And I'm very, very pleased with that. Okay. All right. Let's prototype, make sure everything's working. I roll in, click. I roll out. It'll go back eventually. I roll in. Actually, I believe maybe my play button is a little too close, so let me just move it up here.
I was getting that just when it's alone. It feels like a little sticky.
Yeah.
Until you click off of it once it's on the press color. So you just click and move off.
Yeah, and do I press again and then it goes away? Yeah, I'm going to say that's an okay bug for the moment, because normally when you press a button, there's going to be some sort of action that's driven, so you probably won't see that. I'm sure there's probably just a parameter that I've missed. I'm not going to worry about it for the time being, because the most important part about this is not to really go into the details of how to create fancy looking buttons, but to start working with some scripts and start to throw all these scripts together. Based off of our conversation from last week, what do we need to create? A script that does what?
Basically tells it to either go to the next level or to quit out of the game.
Bingo. We need to direct this button to perform a very specific action. In the world of programming and scripting, life is made a whole lot easier if we understand what the action is going to be before we write the script itself. These scripts are not going to help you out. There's nothing there, we are creating a little piece of machinery here that's only going to do what we tell it to do. So we better understand exactly what we need that machine to do. For me, I need to have a button, when pressed, goes to a different level. Okay? In addition, I also need to have a button, when pressed, quit my game. So very simply, I've described the functionality of my script. That's the hard part. The easy part is trying to figure out the lines of code and the specific execution commands that drives that functionality. Let's create a couple scripts real fast and start working in this world. We're going to create a couple JavaScript here. JavaScript. And I want to call this one play button controller. There we go. And simply double clicking on it will load it into MonoDevelop, our scripting environment. It takes forever to load on these machines.
After a few forevers.
Yeah, and it's even worse for me because I'm live streaming at the exact same time.
Since we got a minute, when you altered your size box for your play button, on mine, I did it using the horizontal and vertical overflow, and then it pretty much does the same thing.
Oh, great, yeah.
You just
Now,
set them to overflow.
yeah, go into your scene editor here real fast, and let's check it out. Now, where? So these are the buttons over here? Yeah, okay, great, cool. That works too. That
Yeah,
works too.
and
So you're just doing, and then it matched the size of the,
Well, yeah, I mean, if set them back,
yeah, it just
it's
truncates
too
it.
small,
Cool.
But if you set it to overflow, it just
It pops in. Great, great, great tip. What Chris stumbled upon was the horizontal and vertical overflow options. That seems to adjust the size of your bounding box to accommodate the content that's inside of it. All right, so welcome to MonoDevelop. As we explored last week, MonoDevelop is our scripting environment. It allows us to see the entire project. If you look at the vertical navigation bar on the left, our entire project is represented in that area. Specifically, I get access at the root level to all of my scripts, but I also have my standard assets directory. It really is looking at my project directory and pulling a number of chunks of information and displaying it on that side of the interface. Most importantly, though, of course, is the center area, which is going to be our new home away from home. Let's zoom in and take a look-see. Okay, so here we go. Here's our scripting environment. Last week we talked a little bit about the role of a function. What is a role? What is the role of a function? To do something, right? It's a container. It's like a briefcase. Now these containers are executed and evaluated at very specific times inside of our game. Through our experience in programming and over the next couple of weeks, we'll start to understand when each one of these functions are evaluated. As one might imagine, when do you think the start function is evaluated? When we start the game. Yeah, you got it. Now the update function is a special one. The update function is always being evaluated. It's being evaluated at every frame of our game. So it's a great place for us to put commands that need to be constantly executed, like key presses or like the jump button or something like that. Okay? A weapon system should probably go on the update function so that it's always looking and listening for a specific command to be executed to drive some sort of action. We'll be using update a lot, I think probably starting next week. Okay? All functions share a very common structure. Of course, we define a function's name here. We tell the computer this is a function. We give it a name. Some names have pre-existing conditions associated with them. Start and update are two of those. All functions are then preceded by a series of parentheses. And then we begin our function with an open curly brace, and then we end our function with a closed curly brace. Yeah? I'm sorry, can you say again? Absolutely. Yeah, we're going to be using them today. It's a great way for us to pass information into our function and filter and say, only look at this component of a much larger structure. Yeah. Okay. For our little button, though, we're going to write our own function. Okay. And this is a function that comes from the Unity code library. So let's start it off by writing function. Does anyone remember what we used last week for our button? On, mouse down, right? Because if you think about the prototype of the script, we need to drive some sort of action when we click on something. On, mouse down. On, mouse down. What comes after the name of the function? Yep. Open and close parentheses. Then what? Open curly brace, and I go down a couple lines just to give me some white space and a much larger work area, and then immediately close curly brace. It's a good practice when you're writing scripts to do those curly braces in tandem with each other. Okay, that way you don't forget to put that closed curly brace in there. Sometimes it happens. It happens more than it probably should, but whatever, it does. Okay. All right. So on, mouse down. Let's prototype the action because we want to make sure before we start getting into the complexities of our code library that this function works, that we're actually registering an action inside the game. Last week, what did we do? Debug. And debug is such a great command because it prototypes functionality, right? It allows us to quickly understand that, yeah, at the very least, we are registering something. We are capturing some information that's coming between the script and the game object it's associated with. So let's just do it real fast. I'm going to tab over, give myself some space. Debug. Debug.log. Now debug.log needs a set of parentheses. And then we end each line, each command, with a semicolon. Okay? FYI, that semicolon is going to be the hitch in your giddy-up. It really is. A lot of times, that's the one thing you forget, is to end the command with that little semicolon. So we really haven't told the computer everything it needs yet, because we want to make sure that we're writing something to our console, which is the role of the contents of our parentheses. Now, we got to put something in quote, because we're going to put a custom string in here, and string is just a fancy computer programming word for text. So we're going to put some text in here. So when we click on our button, I want the console to write, you clicked me. Of course, we've got to put an exclamation point in there because it's happy days. Okay? There it is. Debug.log, open and close parentheses, and then in quotes, you clicked me. Okay? If you ever have any question on how to write some of the parameters and some of the variables of each command, select it. Okay? If you forget, Quincy, that you had to put quotes, or you're just not sure if it has to be uppercase or lowercase, and you just need a little bit of love, a little bit of support, select the command, then command apostrophe, the one right next to the return key, and that's going to automatically take your selection and use it as the search criteria inside the Unity code documentation. And there it is. First one, boom, debug.log. Let's check it out. Ah, wonderful. And I'm going to change my scripting language from C# over into JavaScript real fast. And I love it. They tell you exactly what you're going to need. And they also give you some examples of how to use this. Okay? Yeah. Debug.log and said hello, and then it's also loading the game object that it's on here as well. Pretty cool, huh? So it's always going to give you an example of what it's supposed to look like. All right. Let's hide this. I'm going to save my script, file, save, and then simply Command Tab back into Unity so that I can apply this script to our game object. At the moment, all we've done is written our script. Now we need to take this completed script and do what? You got it. We have to physically attach it to an existing game object inside of our scene in order for the contents of our script to be evaluated. Let's do it. I'm going to simply do this because I'm all about dragging and dropping. I'm going to take my play button controller script and simply drag it on top of my play button. Let's click on my play button game object and take a look. See, yep, there it is. Wonderful. There it is right there. So it's now a component of the play button game object. Now with buttons, there's one more thing that we have to do in here. If we were to simply play the game as is, we're going to play it, and we're going to still get the functionality of our button. But as we click on it, no clicky, right? Nothing's really working yet because there's one more thing that we have to do. Does anyone remember what that last step is? Yeah, so we need to go back into the button script itself and physically create the functionality down here. This thing, the on-click field. Okay, so let's click on the plus sign to add a function in here, and we want this on-click idea to be evaluated both at runtime and while it's working in the editor. Okay. We also need to load the game object that we're working on. I'm just going to grab my play button and drag it down in there. Okay. And now that we've loaded our play button, we can explore it. Check it out. Here's the script that has the action on it. Okay. This is my play button controller. And what I want to do is that I want it to fire off and execute the on mouse down function that is a participant of my play button controller script. Okay? So it's kind of a two-part dance here. We have to load a game object, and then we have to access the script that's embedded or that's part of that game object. And then we have to go in on this last menu here and grab the specific function within the script that we want this button to do. This gives us some granular control. This is actually pretty neat. It allows our simple little button click to do a number of different things. Okay? This adds a tremendous amount of functionality into our game. Okay, so let's fire it off. Let's test it. Aha, rock and roll. Because I can see down here in the console, you clicked me. So boom, high five, Pat. Great job. Prototype works. Okay, we've created a function. We've called that function. We've tested that interaction. Mission accomplished. Yeah, good job. Okay, now it's time for us to actually physically return to our script, edit our on mouse down function, and get everything working the way it's supposed to work. Does anyone remember off the top of their heads? Let me stop my game here. What command we called under the on mouse down function? We did. We did application quit for the quit button, but for application dot load level. You got it. Load level. Yeah, I think it is obsolete. I'm kind of old school. Application dot load level. It should work. Okay, application.load level. There it is. I'm just going to copy that in all honesty. Let's copy it, return to mono develop, and I'm going to paste it in. Now, high score, what is that? Yeah, that's the name of the scene or the level that we're trying to load when we're clicking on this button. Okay? For me, simply I remember that my scene is just level 01, underscore 01, and life is good. Okay? Let's return to Unity, play our game.
It's not built.
That's the thing, yeah. So there's one additional step that we have to do in here, okay? If you look at the error that's popped up at the console, it says level 01, couldn't be loaded because it has not been added to the build settings. Yes, sir?
What was the syntax for the load level after application on? We put 2 semicolons?
I did. Somehow it worked. All right, so let's go back over into Unity. Under my build settings, I'm going to add in main menu. I'm also going to add in level 1. And I don't need to do anything. We just need to have them in our build settings. There we go. And now, when I play my game, level 1 is loaded automatically for me. Okay? So it's a great way for me to test how the editor is evaluating all of these different components. Okay? Now, say again? Yeah, it's super easy. Just File, Build Settings. And then I just dragged each one of my levels over into this window. What's most important is that you have the main menu level be the first level in this list. Think like a computer, right? Computers are always going to start at the top or at the bottom of an evaluation tree, right? For ours, it starts at the top. The first thing that it's going to load when we launch the application is the first scene file that shows up in this list, okay? Everything after that is kind of up to you. It is dependent on how you script it. But the first one is going to be the initial level in the initial scene that Unity is going to load upon launch. Okay. Now, I'm not going to do the quit button, but it's the exact same thing. But I will kind of draw focus to the idea of what we need to do or how we need to change this one line of code for the quit button. So you're going to need to create a new script that's applied to the quit button. You're going to follow the exact same system that we just went through with the play button and wiring up all the on-click functions. It's identical, but this one line of code is going to be different. What's it going to be for the quit button? You're very close. It's application.quit. Application.quit.
I am getting a problem with that.
Okay?
So what I'm doing is maybe it's the way I'm doing it. What I'm doing is because in the editor you can actually set a series of functions for the button on click.
Yes?
So I have that. So I just have in the same script a function for play button click and a function for quit button click. So we can use one script. And then so I wonder if that's a problem because my play button is working perfectly.
I'm not sure. I'll let you explore that. I really don't know.
What's happening is that when I do application quit, it says expressions and statements must only be executed for their side effects.
I don't know. I'll let you explore the solution to that. I really don't know. Okay, let's keep cruising. All right.
Anyone else gets that, let me know.
I'm getting the same thing. Maybe it's, do you have capital quit?
Yeah, I have to quit.
Okay.
All right. Let's keep cruising here. Okay, that was last week. I want to spend our time today talking about something new. Okay, here's my simple, dorky little scene. There's not a whole lot going on in here. It's very, very basic. Okay, and I've done this intentionally just to keep it simple. Whenever we're prototyping and exploring a new idea, I think simplicity is really the king. Okay, I want to turn off my 3D icons as well, just to make it a little bit easier to see. If we play our game, this is what we got going on. Oh. Nothing at the moment. I thought I had placed the first-person controller prefab in here, but I haven't. I have the main camera directional line, a simple ground plane, and a cube. Let's throw in our first person prefab, and I'm going to use the rigid body one. Put that in there. And let's get it on the other side of the cube. There we go. And as I'm looking at this, here's what I'm going to do. I'm going to make my cube, excuse me, my plane, just a whole lot larger. So we have a little bit larger playground here. There we go, lovely. And I'm going to start my player way out over here. And let's just prototype this. Let's just see what we have. That's okay. We can always delete the main camera. So life is good. Just very, very simple, okay? If you ever wonder why we're getting these two audio listeners down here, that's because we have, of course, the first-person controller prefab and the default main camera. You can delete that if you'd like. You actually gain a little performance if you only have one camera sitting in your scene. Because believe it or not, both of those cameras are being run and being drawn at the exact same time. We're only seeing the rigid body one. Okay. Yeah. Yeah, so if you look at the FPS controller, it has a character controller in here. If you look at the scripts, it has a rigid body, it has an audio source. Let's look at this one. It looks like the only big difference between them is the capsule collider itself on the rigid body one. Character controllers are going to be able to detect collision. The first person one, but the rigid body FPS one has an additional capsule collider in there that replaces the character controller. So you're only going to be creating collision in a defined shape now, whose shape is a little bit more representative of a human being, right? A capsule, a football. That's the big difference. Okay. All right. You know what I'm going to do, just to make it a little bit easier for me to see my first-person controller. I'm going to give it a much better icon up here. Let's just give it a diamond. That way it always shows up inside of my inspector, so I can see it easily. That's just for me. Okay. Alrighty, right. So let's start talking about functionality. One of the building blocks inside of our in creating interactivity is understanding how to create and activate triggers. Okay? Triggers in games can be used all over the place. And here's the cool thing about programming. With very simple machinery, we can create very complex results. Triggers, we're only limited by our creativity and our application of this idea. People take triggers to the nth level, and they get really, really crazy and super advanced with them. We're going to look at some very simple applications of triggers and look at the moving parts and look at how we can physically start to wire these components together to create an action. Okay? Does anyone know what a trigger is created from? What game object do we have to have? Not necessarily. An empty, and what kind of component is going to be associated with that empty? A collider, you got it. Colliders are the foundation level building block, if you will, of a trigger. Let's check it out. I'm going to use an empty game object. So create empty. And let's just name this thing. Let's name this trigger. Okay. Now an empty game object is just a point in space. I want to reset its location inside of my transform. So it's right at the origin of my scene. And we want to associate this empty, invisible object with a component, right? Because remember, inside the Unity world, we work and play with game objects. And game objects are really a collection of a whole series of components. The component that we're after is a collider. That collider is going to be one of the elements inside of our Unity system that will register an event. Okay? Let's go ahead and add it. So I have my game object selected. And in the inspector, of course, we can just do add component. And where we're going is physics. And I'm simply just going to do box collider to make my life a little bit more easy. Do box collider. Now, I recognize firsthand that it is very, very difficult to see, but it is that green little, let me deactivate my plane, that may make it easier. And I want to move my trigger away from my cube. There we go. See that little green box? That is my collider. Just a cube. I want to be able to drive some sort of functionality when my player walks through or touches that trigger. Okay? Let's turn my plane back on. Whoop. Grab my trigger, and this is kind of cool actually. They've added some functionality in here which I like very much. If you go to this button, you can edit the collider now. You don't have to monkey around with all these values if you don't want to. It actually makes it really easy. Click on it. Now, in the center of each surface on our collider, we get a little interactive widget, that little cube that will allow us to drag and reshape this collider along all three axes of our cube. Makes it really fast to prototype something now. I'll make it pretty big. Woo! There we go. And turn it off. Let's move this behind the cube just so we have a point of reference as to its location inside the scene. All right, let's play my game and go check it out. Oof. Actually, it's in front of my cube. Oof.
That brings up a good point as well. You haven't selected a trigger.
You got it. And this is the first kind of landmine that people often step on when working with triggers. A collider, at its default state, is an invisible wall. That's all it really is. We have to transform it from an invisible wall to a wall that registers when something passes through it. Because that's ultimately what we're asking the trigger system to do. We want the computer to remember bloop, the moment something passes through it. That's all we're doing. We're walking through a wall and then capturing the precise moment that I passed through that area.
So if you, just as an example, I know this isn't what we did, but if you walk through with, say, begin to loading another section of the level to reduce strain on the computer.
That's something else, but conceptually, yeah, you could do that. Right. You walk into a trigger and then something else happens. Right?
That's
Yep.
used for big open world games too, right?
Well, there's a lot of technology that influences how a different part of the level is activated. In Unity, we have this really cool system called occlusion culling that will handle some of that work for us. So it's, I want you to think conceptually, yeah, that's kind of what's happening, but
Very basic conceptual.
very basic, very basic idea. Yeah. Okay, so what do we need to do to our game object, our trigger here, in order for it to remember a collision, to capture that event?
Check off the is trigger.
You got it. I'm going to hit this little button. Is trigger. Turn that bad boy on. And let's just play the game real quickly so we can understand the functionality. Remember, I'm over here. I need to walk through my collider to get to my cube. Now, watch what happens. Okay? When is trigger is turned on, that collider is no longer an invisible wall. Okay? Its sole purpose now is to understand when an event has happened, when on our game object or when a collision has taken place. Okay? I want to capture that. I want to capture that collision. I want to tell the computer, remember when I passed through this wall, and then to do something. To do something. Okay? So, let's do it. Okay? Okay. So here's my trigger. Let's create a new script. Okay? Create JavaScript. Oops. Let me just open up my my notes here. Go. Okay, cool. All right, so let's open it up. Okay, and what are we going to call this? We'll just call this I don't know, trigger controller. We'll run with a convention here that we've already started working with. Let's open it up in mono development and start getting to work. Okay. Now, in order for our trigger to work, we want to make sure we're replacing its command, its execution instead of a function that the Unity code library understands. So we don't want to do it at the beginning of the game, and we don't want to do it every second. We want to access a very specific function called function on trigger enter. And I've just very quickly added the parentheses and the curly braces to get going here. Oops. So let's just do the classic debug.log again. Debug.log. And let's give it a cool little text here. You triggered me. There we go. You triggered me. Let's save it and apply this script to the trigger game object inside of our scene. So you can drag and drop it on top of there. Okay. All right, let's play the game. Let's see what we get. Aha! Mission accomplished. If you look down at the console, check it out. We successfully wrote something to our debug console. We've registered an event. Congratulations! You just made your first little bit of a trigger. We've asked the computer to remember when two objects have passed through each other. Okay? On trigger enter. It's a great one. Now, as one might imagine, we can extend this a little bit. Let me stop my game here. Okay. Absolutely. It's just, here it is. On trigger enter. Yes, the bane of case sensitivity. You're going to do it wrong 80,000 times before you realize that it's important. You'll get used to it with experience. You know, go back to GComp 402, okay? Remember how hard it was to make just a simple cube, day 2? Right? How difficult it was to make the coffee cup when we first started off. Now we don't even think about it, okay? With experience comes comfort. You'll get better at it, trust me. All right, let's keep cruising here, guys, okay? All right, now check this action out. I'm going to change the size of my trigger a little bit. Now, colliders are interesting shapes, okay? Literally on the surface is just a box. But really what it is, it's a cube whose surfaces are not being rendered. If you remember back to the good old days of GComp 402 when we were learning about the raw surface type, if you will, we defined that every surface has a normal, right? What is a surface normal?
I think we talked about that in 402.
I'm 100% sure we did.
All right. I know that a normal is just the direction it's facing, where X-ray is.
Yeah, absolutely. Every surface has a defined direction. A surface, a polygon, can only ever face one direction, right? That direction is told to the user, and by a number of things, by the normal, right? It's that big line that comes out of the center of the polygon if we have show selection normals enabled inside of Modo, right? Our colliders here inside of Unity work along the exact same idea. Every surface has a defined normal, and our trigger is only going to work in conjunction with that normal. Meaning that our trigger, let me show you what I'm talking about.
So if the box had one side empty, and you tried to approach it from like the inside out, it wouldn't work?
Let's do it. Let's put, you got it. I'm not entering it now because I'm already in it, okay? Notice that my player and my player is inside my, I don't want to do all of them. My player is inside my collider at the moment, right? My trigger. Let's play the game now. I'm going to clear my console. Let's play it. Okay. Oop, I must have been right on it. But as I go in and out, bloop, as I go in, I trigger it, right? Let's do this. Let's really put it in the center. Let's try it now. Bloop. Did I clear it? As I walk out of it, see, nothing happens. It's only going to register when I walk in. Bloop. you triggered me. Okay? Nothing happens when I walk out of it. However, we can capture that information if we wanted to. Okay? Let's go back over into MonoDevelop and extend our script ever so slightly. I want to copy and paste the function that I've already written. Recycle this a little bit. But this time, it's going to be on trigger exit. Okay? You entered the trigger. Then, as one might imagine, you exited the trigger. Okay? Let's see if it works. I've saved my script. Now I'm returning to to Unity. And here, let me put my first-person controller back to its kind of start position. And we'll try it again. There it is. You entered the trigger. You exited the trigger. Mission accomplished. Okay? Yeah. So now we're registering collision on both sides of my box. Okay? Gives us a lot of functionality. Or it can give us some functionality if we wanted it to. All right. Exactly. We're going to get to that here in a minute. Okay? So wonderful. Yay. We've prototyped it. It works. Okay? We're registering an event. Now, let's ask the computer to do something for us, right? Because at the moment, it's pretty boring. It's pretty dull. It's really not doing anything. So let's give it a function. Let's actually ask it to do something. We're going to have it fire off a command. Okay? Let's go back into MonoDevelop, and I'm actually going to nuke this exit one. That was just an example that we can detect our collision on both sides of our collider if we wanted to. But this time, we're going to do something a little bit more entertaining. If you remember, I have that red cube sitting in my scene. It's kind of fun. Maybe if I walk into that collider, that cube is destroyed. Okay? Now we're creating functionality and linking multiple game objects to one script. Let's do it. Could be kind of fun. Okay? Now, before we can get there, let's talk about the actual command itself. And I'm going to take a step back, just to take a step back to show you the command and to show you where we're going. Okay? I'm going to create a new script. And I'm going to call this one Cube Destroyer. Let's look at it in MonoDevelop. Okay? All right. Now, the destroy command is a tremendous amount of fun. Destroy is pretty neat because it really is going to remove a game object from our entire scene. Okay? Let's do this. I want to put initially my destroy command inside the start function. Destroy. Okay. That's the command. Destroy. In the parentheses, however, we have to get a little bit more specific. Okay? Well, what are we going to destroy? And this destroy command comes with a variable, a time variable, when we want to destroy this. We can either destroy it bloop, immediately, or we can have it count down and have it destroy after a time period has expired. Let's do both and see what happens. Okay? So what are we going to destroy? And here's an important part of our vernacular. I want the computer to eliminate or destroy the game object that this script is associated with. So I want to put this script on my cube, okay? So I want my cube to be destroyed instantly the moment the game starts. When you want to destroy or talk to the game object that this script is associated with, game object is lowercase. So we're going to write it like this. Game object. Okay? Lowercase game, uppercase object. So we're saying destroy me, basically. Destroy the thing that I'm attached to. Let's test it. Let's see if it works. Okay? Let's save it. And now I'm going to apply this script to my cube. So cube destroyer, let's just put it on my red cube here. Bloop. Okay. Now watch, everyone just watch. It's going to happen instantaneously, okay? Because the moment I hit the play button, boop, my cube goes away. Not only is it gone from my scene view, but what has also happened?
It's just removed it from the game.
Yeah, it's gone. It's gone, 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 gone. Okay, we have actually deleted this object from our hierarchy. Don't worry, when I hit the play button in game and stop it, it'll come back. But we've actually removed it from our game. Okay? We're going to use this destroy command a lot. Okay? Because if you think about it, when you pick up a key, you need to destroy it. You need to physically remove the 3D model, if you will, of the key from the scene. When you fire a bullet off into the scene, that needs to be eliminated from our scene after a period of time or upon contact, right? You see it all the time in like multiplayer games. You have like dead bodies. You know, the person that you just eliminated in the game, you see their dead body for a period of time and then it's removed, right? This destroy command is something that we're going to use often. Let's go back over into Unity and append it ever so slightly and explore the application of one of our variables. Stop the game, my cube comes back, okay? Let's do it real fast. All right, so we're saying when it's a lowercase game object, we're saying destroy me. I mentioned earlier that there's also an additional variable in here that gets to determine when we destroy it, okay? So it's a what we destroy and a when. Of course, we're going to separate these two variables with a comma. And let's just say after 3 seconds, I want you to destroy me. So that integer there, and I'm going to save it real fast, is going to determine when this action is going to occur. Save it, go back over into Unity, and play my game. 1, 2, 3, poof. There it goes. I was a little fast, but you got there. Okay? So it worked. It didn't destroy the game immediately. It waited 3 seconds, and then it did it. Okay? That's pretty cool. I like that very much. Okay? All right. So now that we understand the destroy command, let's kick it up a notch, right? Let's add in a little cayenne pepper into the mix here and really kind of light this thing on fire. Because really what I want to have happen is that I want to be able to walk into my trigger, then have the cube get destroyed, right? This is going to be a little bit interesting, because in every sense, we have to figure out a way to link the script that's going to be on the collider to understand the cube, to destroy a different game object. Up until now, we've been destroying the game object that the script is on. Now we need to destroy a game object that's not associated with the script, something externally. That's all a question. I want to make sure I get to it. Dylan, do you have a question?
Oh, never mind. No solution.
Okay, cool. So let's do it. Okay. So real quick, I'm going to remove the cube destroyer script from my cube, because that was just an illustration. So let's just get rid of it. Remove component. So I'm in every sense back to me just wandering around. My cube stays. Okay. Let's put the trigger. We'll leave the trigger as is. That's a good place for the trigger. Okay. So let's go into our trigger controller script. Trigger controller. And start figuring out what we're going to put inside of onTriggerEnter. Okay. So what are we going to put in here? What do we want to do?
We enter the trigger. We want the game object to be destroyed in, say, 3 seconds.
You got it. I like it. So when we enter the trigger, we want the cube to be destroyed in 3 seconds. Thumbs up. That's exactly what we want. Here's a great little tip, and I think I've said this already. When you're trying to figure out how to write all this stuff, just say it in kind of a common sentence first. Don't think about programming code yet, okay? Just say it out loud, write it down. When I enter the trigger, I want to destroy the cube in 3 seconds. From that complete sentence, we now can start to reverse engineer it and apply it with some computer code, okay? So we already know from our previous example that the destroy command is definitely the one that we want to fire off. So we're going to destroy, okay? Inside the parentheses, though, this is where it gets a little bit more challenging, right? Because inside the parentheses, we have to define what and when, right? The when's the easy part. That's just a number, right? We did that pretty simply before. It's the what, though, that turns into a little bit of a challenge. Okay? I want to introduce you guys to your very first variable. Okay? What is a variable? It is a thing, absolutely. A thing that means what?
It is a container for a value.
There it is. I like it. It's a container that contains a value, and we get to define what that value is. That value can be a number, it could be a letter, it could be a game object, it could be a script, it could be an audio file, it could be any number of different things. The variables can be many different things, but we get to define what they are. Okay? Sometimes we can even ask the computer to define them automatically for us. Okay? They're designed to allow us to infuse a certain degree of flexibility inside of our world. We don't have to hard code everything. We can ask the computer to search our scene for a number of different things and then use the conclusion of that search to drive our function. Let's make it easy first. We'll do an easy variable, and then we'll do a more complex one at the end. Okay? So I want to be able to make a script that's a little bit more universal, where I'm not hard coding in. Thunder again? That's awesome. I don't want to hard code in a specific value in here, right? Because now I have to make an individual script for every single thing that I want to destroy, right? We want to try to make our scripts flexible, malleable, expose certain variables in the inspector to make our life a little bit easier. And that's what we're going to do. We're going to expose our variable. At the top of our script, I'm going to add a couple line breaks in here, and I'm simply going to write my first variable. And let's just do this. I'm going to write var. We're creating here what's known as a public variable. This public variable is going to be accessible, and it's going to show up in the inspector back in Unity. Awesome, okay? And we're going to be able to control the contents of this variable in the inspector because it's public, okay? It's available to everything instead of Unity, including us in the editor. And let's do this. I'm going to call it my target. Okay? Now that's the name of my variable, and you literally can call this anything. You can call this Alex Crazy Target, Alex Super Thumbs Up Awesome World. You know, whatever you want to do. It could be anything. It's just a name. Okay? However, what follows our name, okay, is important because now we need to define for the computer exactly what this thing is. Okay? We do that with a colon, okay? And this is going to be a game object. Capital. And FYI, if you would like, you could also put a space in between your colon. That works too. It doesn't make a difference. That's a little bit easier to read, a little white space in there. Makes it a little bit more legible, okay? So we've defined a public variable called my target, or excuse me, we've created a public variable called my variable. It's Friday afternoon, my brain's gone to mush. I'm sorry. We've created a public variable called my target, and we've defined its container to be a game object. Okay? It's not a number, it's not a picture, it's a game object. It's something that exists inside of our three-dimensional Unity scene file. I'm going to save it, and I want to show you something. Let's go back into Unity real fast and check it out. If we go to our trigger game object itself, well, we don't have any. Did I put it on there? Trigger controller. It's not showing up yet, but once I actually access that variable and use it, it will show up down over here. Okay? Let's go back into MonoDevelop real fast and do something with onTrigger. Okay? Now that we've defined a variable, let's call that variable. Let's tell the computer, hey, whatever I put in this container, destroy it for me. Okay? So what are we going to put in here? Does anyone take a guess? My target. You got it. My target. I'm going to copy and paste it. Yeah, so comma, and then I'll do it after 3 seconds. Okay?
I'm going to right-click the log and then 2 seconds later.
Okay, let's save it. Let's go back over into Unity. Okay. Yeah. See, now that I clicked off of my trigger, and then I clicked on it again, which reloads the script, check it out. Now my target is exposed in the inspector, and I get to tell it from kind of a generic point of view, specifically which target I want to destroy. Now, what do I want it to destroy? The cube, right? So I'm going to left click and drag the cube whoop, into this hole. Boom. Okay? So at the inspector now, so I'm not hard coding this in. I didn't need to remember its name. I made it general. I made it kind of universal, if you will, with this variable. By making it a public variable, I exposed it over here in our inspector. Yes, sir?
I didn't think this would be an issue, but in the component section for the script on their trigger, for pretty much every single one of everything in my hierarchy, all the scripts are grayed out, like the names of all the scripts are grayed out, and now it's not even allowing that thing to update. So yeah, so I don't know what like if I were to add
Okay.
what is it?
Let's do this. Let's go back into your trigger real fast.
Totally, yeah,
Trigger. Delete your trigger script.
sure thing. Remove it or delete it?
Remove it,
All right,
yeah.
cool, yeah.
Now, add it back on again. See if that makes a difference.
Yeah.
Okay. Ooh, here we go. We're getting an error. Okay. Double click on the error.
All right.
We did not capitalize the word destroy.
Oh,
That's why it was failing. Yep.
Gotcha.
That's
Okay.
it.
thank you.
So Dylan just ran into something that I think is a really good thing to point out. And I'm going to intentionally break my script so that we can see it in action. Okay? I'm going to do what Dylan did and put a lowercase d for the command destroy. I'll save it and return to Unity. Okay? All right, yes, okay. So if you ever see an error down here in your console, check it out. It's telling you exactly where the problem resides. It's saying, hey, you have an asset. It's called trigger controller JavaScript. Okay, so it's a problem with our script. It's even telling us what line. Okay, it's on line 14. And it's saying unknown identifier destroy. Okay. In addition, if you don't know what that means, if it's all garbly-gook, okay, sometimes I don't even know what it means. I go, whoa, what's that? If you double click on that, it'll take you to the line that's causing the problem. Bloop. Yeah. See, did you see, I don't know, it happened very quickly. Did you see it highlighted that line for me? Yeah, and to answer your question, Quincy, you had to redo punch cards often. Yeah, my father told me that when he was at the Air Force Academy, of course he did some computer programming with punch cards, right? And if one of your cards was broken, right, if you didn't punch it correctly, you would have to go in and figure out on each card where the error was, experiment, fail a whole bunch of times, and then through the process of elimination, you'd figure out where your problem was. Yeah. Crazy, right? So happy we've advanced from there. Yeah. My father said that when he was at the Air Force Academy, he remembers going to the computer lab with big milk crates, and the milk crate was just full of punch cards, and that'd be the script, the program that he'd asking the machine to do. Okay, cool. Let's see if it works. Let's see if it works. I'm excited here. Okay. So I saved my script. I just want to triple check everything. Here's my trigger game object. I've loaded in my target. I'm not getting any errors down here inside of my console. I'm ready to rock and roll, man. Let's play my game. Okay, now here's kind of a good tip. When you're prototyping the functionality of your script, have both the game view and the scene view open at the same time so you can see precisely what's happening. It's good to get a visual confirmation that you have, in fact, walked through the collider. Let's do it real fast. Bloop. Let's see if it works. Mission accomplished. Rock and roll, man. Awesome sauce. Okay. Pretty neat, huh? Yeah, absolutely.
And the Unity help website has these, what we search through, they have these scripts up there, some of them up there.
No. No. Well, they have the commands up there. They don't have these scripts up here.
No, they have like the commands which we can form into.
Absolutely. The code library on Unity and the documentation is quite good. What's a challenge is that if you don't know what you're looking for, you don't know what you're looking for. You know, there are thousands of commands that the Unity game engine is going to register, or that does register. So if you don't know specifically what you're looking for, it takes a while to find that result. Okay?
So this is Pandora's box.
No. Hopefully you're taking notes. Okay? Reference the live stream to kind of get a refresher of this. Hope you guys are all of you guys are following along. Save these scripts. Okay? Here's what I do, and this is a small representation of a much larger world. Okay? I've told you time and time again that I'm a big believer in Evernote, right? Okay? I know this is impossible to see from where you guys are. Okay? Evernote. I have a notebook in Evernote called Code Library. It's just full of code snippets. That's all it is. Little nuggets of code that I've extrapolated from my years of experience doing this that I've saved. Okay? It's not about knowing every single command. That's impossible. Okay? There are very few people, the savants of the programming world will remember every single command and the structure of every single line of code. For us human beings, it's about knowing where to find your answers, not actually knowing them. Yes, sir?
Testing there, we have three or more cubes. When the three are like three more cubes.
Yeah, so let's prototype that. So that's the next question. I'm going to do this very quickly because I'm running out of time, and for that I apologize. Okay. It's a game object, or is it game object? Yeah, I think. Okay. So what if we have 3 cubes? Okay. Let's do this. So I want to duplicate this cube, and duplicate another one. Now, clearly, I can't load in all 3 of those cubes into my script, right? So what am I to do? I got to think about it from a much different perspective. Okay. Let's do this. Okay. Now, I wasn't planning on doing this today, but since Tim asked, let's just proof of concept. Okay. One of the things that we have access to inside of Unity are these wonderful things called tags. Okay. Now, these tags can give us a much larger framework to play within. Okay. I'm going to access these for a second. Okay. I'm going to create my own tag. Add a tag in here. Let's see. What am I gonna do? I'm gonna call this bad cubes. Okay. Bad cubes. Okay. And now that bad cubes tag will be available. I'm going to tag all of my cubes with bad cubes. Okay. If you put this out into a much larger world, this could be enemy. Okay. If I pass through this trigger, or if a collision event happens between like a bullet and an object, and if that object has been tagged with enemy, destroy that object. Okay.
So it's like checking, almost like checking for if it's of a certain class, but it's basically you do the same thing.
Kind of, yeah. Kind of. So game object dot tag. Make sure I'm writing this correctly, and then I got to put equals. Oh, not find with tag. That might work. Let's just go with what I know. Is was it bad cubes? Okay. Let's save it. Let's see if that works. Do find with tag. See what happens. And I may be writing this wrong in that I think I may have to put this in. Yeah. Yeah. Let's try this. Hold on a sec. Like I said, it's not about knowing. Yeah, it's not about knowing where to find it. Yeah, I'm writing this wrong, but this is the idea behind it. You can tag multiple objects, and then when you pass through the collider, anything that's tagged with that, bad cubes would be destroyed. Yep. Yeah, if you wanted to destroy just one of them, the system that I showed you earlier. So yeah, this is a great way, going back to the earlier example that I had. Okay, this is a great way of doing it. Okay, great way of doing it. Yeah, because the way we've written this is we're telling it to destroy, but then we're loading in a variable where we would normally define the game object, right? Now in the inspector, since that's a public variable, that variable will be available to us in the inspector. Okay, and oops, let's go back into my scene view. Now I can load in a cube. So instead of being that cube, I can grab this one. Oops. And drag it in there. Okay. Which one is that? That is the rightmost one. So once I walk in, this guy's going to go away here in a second. It goes away. Okay. Potentially, yeah. Potentially. Yeah, if you're trying to do multiple things at the same time, we have to change our strategy. Baby steps. We'll get to that point. Okay? All right. So it's about quitting time here, folks. What I want to do, or what I'd like you to do for next week, is to go ahead and start fleshing out the art assets of your video game. Okay? Start getting a little bit more detailed with how your game environment's going to look. We should start seeing final shapes next week, as close as we can. Just the geometry. Don't worry so much about the textures, but we should be marching closer and closer and closer towards, final geometry for our level next week. Okay? I've placed a Dropbox on D2L. Please bring your project file with you next week. We're going to look at your games once again and start evaluating the art assets. And then you're going to upload an application. Oops, let me go into D2L. Here it is. So this is what we prototyped today, the simple prototype. If you haven't uploaded it, please upload. And then this is what's due for next week. Okay? Art assets. Questions on what we're going to be building for next week? Good luck. We'll see you next week.
For the one that was due at 4:30,
Mhm.
is that the one we did, that we started Friday for the ones that didn't finish? Or is that different?
Hold on 2 seconds, okay? Let me just stop my live stream. Okay. All right. So last week at the conclusion of class, what was asked was for you to go back in and continue to revise your prototype. Add the stuff that you didn't have time to do, because almost everyone didn't have time to finish their prototype.
Oh, yeah. Okay.
Put that in the first Dropbox on D2L. Okay?
I put that in the old Dropbox from the...
Would you mind, please resubmit?
Yeah,
Yeah.
I can do that.
Great.